Hello everybody, you're very welcome to this episode of Programming and Algorithms. In this episode we're going to look at how Python implements stacks and queues as an array. So we've looked at it in pseudocode and now let's look at it in Python. So we'll start with stacks. We'll remind ourselves that a stack is a pile of stuff and it adheres to the principle of last in, first out, or LIFO. So that means the last element that's added to the stack is the first element to be served. We add to the top and we take away from the top. That's the only way we can access elements from the top. We can't access them from the middle. So in Python, as in pseudocode, we implement a stack by creating an array called stack. We have a maximum length of the array called maxSize, a variable, and we have a variable called stackTop that tells us what value is currently at the top of the stack. So that's a pictorial representation of it. Here's some Python to declare the stack. So in this case, we've created a stack that has 7 elements in it. The first 4 have values in them, and the last 3 I've just stuck zeros in to show you that they've no values in them at the moment. So I've said stack top is at value 3, which means array element number 3, which is the 4th element along. So it's pointing to the number 26 in this case. 31, 41, 59, and 26. That's element number 3 of the array, which is the 4th element, and everything else is empty so far in the stack. So I hope that makes sense. How many elements can we add to the stack? 1, 2, 3. 3 more elements we can add. When we get to the 3 elements added or pushed, what do we do then? We can only pop. Once we pop, we're pushing the values down again. So we're going to look at how to implement the following modules, or methods as it might be called in Python. Is full, is empty, push, pop, and top. So let's look at the code to check if it's full. Well, there's 2 ways of checking if it's full. One is to check if stack top plus 1 is equal to max size. Then we can return a boolean stack full equals true, else we can return a boolean that stack full equals false. I think what's important to note here in the Python is we have a variable called stack top that's going to be used that tells us what's the top of the stack. Because it's used in multiple different methods or modules, we have to, each module we use it in, we have to tell Python that it's a global variable. So we looked at global variables before. The idea is that a global variable is one that all methods or modules can see. If I don't declare that as global, the program won't know. If I change it in isFull, it won't get changed globally. Whereas if I don't declare it as global, it won't know what value stackTop has. If I declare it as global, it means find me what the last value of stackTop is. So we talked about scope before, and that's an example of scope. The boolean stack full is local scope, whereas the variable stackTop has a global scope. And we can do that much quicker by just checking if stackTop, which is a global variable, is equal to max size. Perfect. If we want to check if the stack is empty, we just check if stackTop is equal to -1. And if stackTop is -1, then we can declare a boolean stack empty is true, else we can set the boolean stack empty to be false, and then we return stack empty. And again, we'll remind ourselves that the variable stackTop must be declared as variable, as global within this method. And the shorter way of doing it is just by simply saying global stackTop, return stackTop. If it's equal to -1, the stack is empty. If it's not equal to -1, then the stack has values in it. How do we push a value on? Again, we need to remind the program that stackTop is global. We check if it's full. If the stack is full, then we just print out a message saying stack is full. Else, we add 1 to stackTop, and then we write the value n into whatever the array stackTop is pointing at, the value stackTop in the array stack. Let's look at popping a value. We set a variable in to be 0. We again remind the system that stackTop, this pointer, must be available to all methods. If it's empty, the stack, then we print out a message saying the stack is empty. Otherwise, we write the value n with the value that's currently pointed at by the stack top, and then we take 1 away from the value of stack top. Now, when I take 1 away from stack top there, because I've declared this variable stack top as global, all the other programs will know that 1 was taken away from it. If I don't declare it as global, if I take 1 away from it in this method or module, the other methods or modules won't know that that decrementation has occurred. So I need to tell everybody else, look guys, I'm taking 1 away from this guy here, and you need to be aware of that. If we just want to do top, which means just show me what the top value is, but don't take 1 away, it's exactly the same as pop, except we don't decrement stack top by 1. So technically speaking, we probably don't need to declare stack top as global there, but it's as well to anyway, because we are using the value of stack top. Anytime I have a variable that's going to be in a lot of different methods, for Python I need to declare it as global, otherwise it won't know it's global. And we'll remind ourselves as well, just looking at the def at top, on the top, when we declare a method, we declare it using def for define that method. So that's our stack. Queues, similar principles. We remember queues, it's first in, first out. Whoever gets added first to the queue is the first person to be dealt with. So we take away from the back, or we add to the back, I beg your pardon, and then take away from the front. So add to the back, take away from the front. To do queues, it's exactly the same as in pseudocode. We declare an array called queue. We have a maximum length called max size. The front of the queue is called head, and the back of the queue is called tail. So that's a conceptual representation of it. Queue, array, head and tail, max size. If we declare it in Python, what does it look like? In this case, we've declared a queue that's of length 7. The head of the queue in this case is at the 3rd element, or queue head is at 2, and queue tail is at 5, so the 6th element. So that means the 7th element, the last element is 0, and the first 2 elements, elements 0 and 1, are 0 as well. I know in pseudocode I said we'd call these variables head and tail, but in Python I've called them queue head and queue tail. There's no particular reason for that other than that I'm nervous that head and tail might have some special meaning in Python, or they mightn't exactly be clear as to what they're like. Given that we're calling the top of the stack, stack top, let's call the pointers queue head and queue tail instead of head and tail. Just to remind ourselves that we're looking at queues here. This is just me being fussy. When I implement algorithms in pseudocode, I'm a lot looser because it's a design language. But when I implement them in a programming language, I really tighten up on my variable naming. Same if I'm an architect, I can draw rooms on blueprints and it doesn't matter too much. Whereas if I'm the builder building the rooms, I need to be very sure that the rooms are going to stay up. And in the same way, when I design code and pseudocode, I can be a little bit loose, whereas when I implement in Python, I want to be very accurate. And I want to test my code a lot as well. So we'll look at how to implement is full, is empty, add to queue, delete from queue, and clear the queue. How do we check if the queue is full first? The queue is full if the queue tail plus 1 is equal to max size. So we can have a Boolean variable called queue full, and it's either true or false, and we return it true if the queue is full, and we return false if the queue is not full. The only thing to note in Python here is we have to declare queue tail as being a global variable so that all the other methods or modules will know that we're messing with queue tail here, or we're examining the value of queue tail. We don't need to do queue head because we're not looking at queue head in this case. And we can do it a little bit quicker by just saying global queue tail, and if queue tail plus 1 is max size, then we know the queue is full. Let's look at how the queue is empty. We know the queue is empty if the queue head and the queue tail are pointing to the same value. In this case, what that means for Python is both of them need to be declared as global. For examining both of them, then we should tell Python, look, we're looking at these two values, so in this method, but I want to let all the other methods know that I'm looking at these values at the moment. So if the queue head is equal to the queue tail, then the queue is empty. If the queue head is not equal to the queue tail, then the queue is not empty, and we'll return the Boolean QEmpty. We can do it quicker by just saying global QTail, global QHead, return QTail equals QHead. How do we add a value to the back of the queue? We need to say, if we're adding to the back, then we need to let Python know we're messing around with QTail. So we declare that as global. Then what we say is if the queue is full, then just print out the queue is full, else add 1 to the QTail, and then write the value n that we're writing in to the location that QTail is now pointing at. How do we delete from the queue? Well, when we're deleting from the queue, we're messing with the variable QHead. So again, we say that's a global QHead. I want to tell everybody I'm messing with the variable QHead. If the queue is empty, then we can't delete from the queue, so we print out the queue is empty. Otherwise, whatever value is at the front of the queue at the moment, we write that into the variable n, and then we add 1 to QHead, and then we return the value n. So when we add 1 to QHead there, because we've declared this value as global, all of the other methods and modules will know that 1 has been added to QHead. Otherwise, they won't know. It'll only happen within the scope of this method if I don't declare it as global. Whereas if I declare it as global, I'm saying all of you guys need to be aware of this. How do we clear the queue? Well, it's simple. We set QTail to be -1, and we set QHead to be the value of QTail, which is -1. And again, to say it, that means global QHead and global QTail. Okay, so let's look at how to implement circular queues now. So a circular queue is one where the front of the queue is joined to the back of the queue. So that means if I've taken elements off the front and I keep adding onto the back, if there's space at the front, then I can add them onto the front again. So we know how we do this is by using division remainder. So if the maximum length of the queue is, let's say the queue is 10 elements long, that's elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we added 1 onto 9, we would get 10, but we don't want 10, we want it to go back to 0 again. So if it's 10 elements long, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We do that by doing division remainder. So for a circular queue, it's the same as a linear queue. We have a queue array called queue. We have a max size called max size. We have the front pointer, which we can call head or QHead, and the back pointer, which we can call tail or QTail. And that's conceptually what it looks like. It looks exactly like a linear queue, except because we're doing this division remainder stuff, we can wrap the tail around onto the head. So here's a circular queue declared. In this case, we have 4 elements in the queue. It's 7 elements long, but the first and second element, elements 0 and 1, are blank. Then the first element, which is a QHead, is number 2, 59. Element number 3 is 26, element number 4 is 53, and then element number 5, which is the QTail in this case, is number 59, and the element number 6, the 7th element of the queue, is empty. So just for fun, I've set those values to be 0. We could have numbers in it, but the array wouldn't be able to access those numbers anyway, because the methods we're using will only allow us to look at values between the head and the tail. So those zeros could be 999 each, and we would never see those numbers until a value is either written into that or read out of it. So we'll look at how to implement if a circular queue is full, if a circular queue is empty, adding 1 to the queue, adding a value to the back of the queue, deleting from the front of the queue, and clearing a queue. So how do we check if the queue is full? Well, it's simple. If the queue head is equal to the queue tail, then it's full. If the queue head is not equal, +1. If the head +1, if the head is equal to the tail +1, it's full. Otherwise, it's not. And we can do that either one of 2 ways, either by having a Boolean or just returning QHead equals QTail, max size. And again, it's worth noting that we use the global to tell all the other methods in Python that these variables are in use in this method. How do we check if it's empty? We check if it's empty if the QHead is equal to the QTail. If they're both pointing in the same position, then we know it's empty. And we have a variable called QEmpty, and we set it to true if the head is equal to the tail, and we set it to false otherwise. We can either do it using a Boolean, or we can do it using the shorter way of just saying QTail equals QHead. How do we add to the queue? well, what are we changing when we add to the queue? We're changing where the queue tail value is. We're also getting the max size. The max size is going to be the same, it's not going to change, but it's good practice to declare that as global anyway. And what are we going to do? If the queue is full, we can't add to the queue, so we just print out a message saying queue is full. Otherwise, whatever value we want to add in, we add 1 to the tail, and then we write that value into the new position. How do we delete from a circular queue? If the queue is empty, we can't delete, so we just say the queue is empty. Otherwise, what we do is we store whatever value is at the front of the queue at the moment into a variable called n, and then we add 1 onto the head, moving it backwards, and do our division remainder. And because we're changing the value of queue head, it's very important we declare that as global in Python. How do we clear the queue? It's simple. We set queue tail to be -1, and we set queue head to be equal to queue tail. Again, because we're changing both of the values of queue head and queue tail in Python, we must declare these as global. Otherwise, if we didn't declare them as global, what would happen is queue tail would be set to -1 and queue head would be set to -1 as well in this method. But as soon as we got to end clear queue and it finished this method, those changes wouldn't have occurred to all the other values of queue tail, because what happens is this method clear queue takes a copy of queue head and queue tail. It changes the values in the copy. And if I don't say global, it doesn't write those changes to all the other copies of queue head and queue tail. It just changes the local copy. Whereas if I say global, it means change all of the other methods and modules can see the changes I've just made. So thanks very much. Over to you now. It's up to you to play around with queues and stacks and see how you can use them. Thanks very much. We'll see you on the next episode.